In this video, we are going to solve some problems based on Doppler's effect. A motorcyclist approaches a stationary police car with a speed of 15 meters per second. So we have got a motorcyclist and a police car. We are going to draw a diagram to understand the question better. A motorcyclist approaches the stationary police car with a speed of 15 meters per second. So we'll draw an arrow to show the speed, which is 15 meters per second. Police car emits a sound with a frequency of 500 Hertz. That means police car is our source and the frequency is 500 Hertz, which we can write as Fs equal 500 Hertz. The speed of sound in air is 340 meters per second. So V is equal to 340 meters per second. Then we need to decide where is the positive direction. It is taken from source to the detector. So we can see that the red arrow which I have drawn is showing you the positive direction for this problem. Motorcyclist is traveling opposite to the positive direction. That means the velocity of the detector or the speed of the detector will be taken as negative 15 meters per second. So we are putting a negative sign because motorcyclist is moving in a direction opposite to what we have labeled as positive direction. Now the formula for Doppler's effect is Ft equal Fs, V minus Vd over V minus Vs. Fs is 500. V is 340, Vd is negative 15. So already there is a negative in the formula, so negative of negative 15. Then over 340 minus, the source is stationary. So that means police car is not moving. So the speed of the police car is 0, source is stationary. We substitute this values and then put it into the calculator. We'll get the answer as 522 Hertz. State and explain what happens to the wavelength of the waves as they reach the motorcyclist. As the motorcyclist is coming closer to the police car, their wavelength would decrease because the wave fronts will come closer to each other. So the wavelength will decrease because also we can see that the frequency is increasing in part A. We can see we got the frequency as 522. Frequency increases and therefore the wavelength will decrease. A hiker shouts towards a vertical cliff which is at 465 meters from him as shown in the figure below. The echo is heard 2.75 seconds later. What is the speed of the hiker's voice in the air? So we'll use the formula for echo, V equal 2 times the distance over time. All the values are given to us. Always remember to double check the distance. Here the distance 465 is the distance between the hiker and the cliff. So we'll substitute it as the value for D, and we have to double it because the sound will travel from the hiker to the cliff and back again. So that gives us the value as 338 meters per second.